So the last example we have to do today is about something called an oblique prism. So oblique prism would be if you have basically the same exact prism and the cross sections are the same, meaning if you chopped it, every time it'd look identical. And they're going to have the same volume, which means I mean, we have these two square pyramids here. I always like to instead picture a stack of pennies. So you can stack some pennies up vertically, or you take that same stack and like slightly push the pennies sideways. So they might still have the same exact height between these two stacks, and every time I would pick up part of the stack, it would be the same penny, but I just shoved one sideways. So this one is an oblique prism, and this one is called a right prism. But the thing is, you don't have to care about that because the volumes are going to be the same. So we're going to find the volume of this oblique prism in cubic meters. So it's a prism. I'm still thinking area of the base times the height. It is technically still a square prism, like most of them you will encounter in this class. So I'm going to still think length times width times height. So it doesn't matter if it's slanted. The slantedness is irrelevant. Nobody cares. What we care about is the height, meaning if this was some weird building and you were standing at the top and you dropped a coin or a ball or something, we want the height from top to bottom. Or if you were standing at this corner of the building and dropped a ball, I want the height that it would fall, which means 3.2 meters is the height. It's kind of drawn outside the picture, but it's still the height. So 3.2 meters is the height. And when I talk about the base, it doesn't have to mean the bottom, but it pretty easily could mean the bottom for this one. So I'm talking about this rectangle. So I'll take 2.7 meters times 4 meters times that 3.2 meters. So I'm going to grab my calculator. It's spitting out 34.56, and again I took meters times meters times meters. Anything times itself 3 times is cubed, so this is meters to the third power. Basically, if you see something shoved sideways, pretend like it's not. Pretend like mentally you could shove it straight up and down again.